Okay, good morning. It's a pleasure to be back here in Korea and to talk about 6G, the latest of our Gs. By the way, I must say I'm a little stiff. I spent the weekend hiking up in the mountains, here climbing up in Bukhansan. So quite a wonderful weekend to do that. By the way, let me just start talking about the Gs, and I'm going to talk in my presentation, I'm going to talk about some of the challenges, some of the benefits that we expect from 6G, and Yuho has just showed you a lot of the little technologies that Samsung is thinking of bringing into the standardization process and all for in 3GPP. But I'm going to get less into the absolute details and get into some of the real challenges here that we've also faced, plus, as I said, some of the values. So we've gone down and, about every 10 years we've created a G, and I think most people who are familiar with that quite realize that. And so the question that is often asked is, well, 5G has not been successful, okay? Well, I actually refute that a little bit, and I'll talk about that on the next slide. But I think we can also look at that 6G will be successful and hopefully even more successful. If I were to take the recommendations of the ITU director, Onoe-san, who used to be heavily involved in and probably spoke at some of these events in the past, he would have said, even Gs are magical. Odd Gs are less questionable. I always refuted his comments because I thought some of the 3Gs and the 1Gs were very, very also important. But let's go see where we happen. So, talking about success, okay, large number of smartphones out there. It's not been for the smartphone market, it's been a very good market, okay? Operators, large number of operators have deployed it. Okay, enhanced mobile broadband is working fine. Yuho showed, hey, the gains, particularly in the United States. People have said, oh, millimeter wave is not a success. Well, we're actually to have a pretty good deployment of millimeter wave in the United States. Verizon is continuing to deploy millimeter wave sites out there. Yes, hey, once the C-band, the lower frequency bands came along, it's a little bit easier to work with. It got better in building penetration at the lower bands, so the operator's natural inclination will be to deploy in the lower band. But I believe that we have a long way to go in millimeter wave deployment, and millimeter wave technology. Take a look at, some people talk about the costs, for example, of large antenna arrays that we're using at millimeter wave because we need the antenna directivity to help close the link budgets. But if we look at some of the stuff that Elon Musk company, Starlink, has done for building user terminals at Ka band, we can replicate much of the same type of technology, okay, and get to good pricing on that. So let me move on here. And let's just talk a bit about the services here. Well, the first thing that's obvious is basically ultra-mobile broadband, enhancement of basically the internet type experience on mobile, and of course with that, the voice activities and such on. But we're seeing, one of the things that we're seeing now in 6G, in 5G, is more and more the expansion into these other use cases. Yes, it hasn't picked up quite as fast as many of us had hoped, but it really takes time to work down these various user communities. We're seeing, for example, in some of the critical services, more and more interest in really using our cellular type technology in these things, primarily because of the coverage, the capabilities of it, and the cost structure that we can bring to many of these things. Robotics has been around. Maybe in the future we'll be able to get hologram telepresence. If you remember, what has been one of our biggest successes in the past 5 years, driven by the pandemic, is virtual meetings and virtual communications. So I can now go from my office, okay, where maybe I'm connected on Teams or some other Zoom type application, jump into my car, continue that over video, okay, go home and reconnect in the local environment. all working together nice and seamlessly here. Yes, we can thank the over-the-top apps such as Teams or Zoom or something like that, but it's also to the underlying communications that we have provided for us, both wired and wireless, as part of the last few years. Okay, smarter verticals, they're coming. It takes time to develop them out there, and it takes time to work with them so they understand the technology that we bring to the market and we can use. Okay, XR experiences, it's coming. Not as fast as we had originally expected. Takes a lot to really get the technology of the glasses and the goggles down. Sensor fusion, human augmentation, I will jump to the next area. So what is the vision of this? So the ITU has put together this vision, which expands on the vision that we had for 5G. 5G was enhanced mobile broadband, ultra-reliable, low-latency communications, and massive machine-type communications. As I said, the enhanced mobile broadband has done wonders, but some of the others haven't. But what we've taken for 6G is sort of expanded upon this and brought in the concepts of, hey, we're going to include AI capabilities in this. We're going to try to go for ubiquitous connectivity, really talking about getting our coverage better, connecting the remote users, bringing them in and other things. And then this new area of integrated sensing and communications. How do we use our communication systems to learn more about the environment around us, what's happening around us? But wrapping around this is probably the most important piece of this, which is sustainability. And this gets into what I will call affordability and the green needs. So one of the big costs of the operators today is actually the cost of actually running their system, electricity cost. How do we make a substantial dent into those costs, okay, and be smarter in the way we run our systems? And some of this we're going to address in the standardization. Some of it a lot is about implementation and really focusing on implementation on the infrastructure side. For years, we've had great, how do I call it, pull or push to make the devices, the handsets and all of that, very power efficient. But as we move forward, we need to do exactly the same thing on the infrastructure side so that we basically reduce the operating cost for the operators and also allow them to deploy more cells, which will actually help on coverage. Now, let's go look at the standardization process for 6G. And Juho showed a slide quite similar to mine here. Basically, I think we've been working in 3GPP. There was a workshop back in May on use cases. Okay, really looking at sort of what the use cases are. Of course, there's been discussions in the ITU between companies and things like that. But to me, the real start of the process is going to be this workshop next March, held here in Korea, okay, which is really going to kick off, as we've done for many of the last Gs, 3G, 4G, and 5G, we've had a big workshop, which has sort of helped kick things off. And we're going to do the same thing right here for basically 6G, and various companies will bring in and provide their technology visions, hopefully. And from that, 3GPP will be doing a number of studies, what we call through what we're time frame of, say, release 20, time frame of 3GPP, and then actually move into formal work items, okay, and leading to standards around the end of the decade. Exact date, as Juho indicated, has not yet been decided, set by 3GPP. So, what are some of the key things that we're going to bring in here? Okay, AI native communication. So we're going to bring the AI capabilities in, and I'm going to talk more about that later. Sort of relook at some of the network architecture. We've been really playing a lot with the network architecture, making more virtualized over the last few years. We've sort of been opening it up, and particularly in the RAN, I'll talk about that later, opening that up a lot more. There's a bunch of area innovations, maybe focus on much more resiliency and security aspects. And I'm going to talk a little bit about spectrum, because that is one of the key areas of that we have to deal with. And one of the reasons I'm talking about spectrum here is to some extent the US and Korea have somewhat similar constraints. We have both allocated the upper 6 gigahertz band to unlicensed operations, and therefore we're challenged. So what is a new band? And some of our constraints are very similar. But let me just talk a little bit about, give a little bit of background. First, about every 3 to 4 years, the ITU has these World Radio Conferences. And these basically look at identifying spectrum around the world and by regions or by footnotes, which basically are countries potentially within regions. Okay, we just had one in WRC 23, basically end of last year. And if you look at what I've tried to show here is the various increases in identification of cellular spectrum, or IMT spectrum to use the term, over the various WRCs. Now, if you look at the bottom, you see a big jump up in WRC 19. That's due to the identification of the millimeter wave spectrum, 24, 28, 37 gigahertz band. We got a huge amount of spectrum there. That was good and bad. It's good because we have access to a lot of spectrum. But on the other hand, in certain parts of the world, some regulators have said, oh, we got tons of spectrum. We don't need any more for IMT. I will refute that in saying the following. Yes, but we know the building penetrations and some of the challenges of millimeter wave requires a higher density of cells, or we have to use the millimeter wave cells much more intelligently in conjunction with lower frequencies. So let's say that. And we did a little bit of additional allocations in WRC 23. I'm pointing out the 3 ones in red, and we'll talk a bit more about this later. 6425 to 7025 in region 1. This is what we call the upper 6 gigahertz spectrum. Okay, now in the US and Korea, that's what's been identified for unlicensed operations. So we also identified 7025, 7125, and then 10 to 10.5 in region 2. Unfortunately, this 10 to 10.5 in region 2 is not included in the United States, and it's lower power. So it's a decent band for small cells, but the operators would like to have a band which gives them much better coverage. So let's look at what's happening. So for this band that's the upper 6, in Europe they're doing a lot of studies, and it's unclear how it's going to actually pan out. Okay, there's studies of, is it going to be everything from fully used for cellular IMT? It will be some sharing arrangement with Wi-Fi, some band split, and all that. I'll not get on the details, happy to talk about that during a break or something. Okay, next set. What's been looked at now for WRC 27, the next one? Studies at the 4.4 to 4.8 gigahertz band in certain regions. Difficult band to actually use because of incumbencies. One that we're going to talk a lot about is the 7 gigahertz to 7125 8.4 gigahertz band, because that's one that's being heavily targeted by a lot. And then there's looking also at across all the regions. Actually, all these bands are being studied in all regions, but there's only on the table for potential identification in certain regions. The 14 gigahertz band there, higher than liked, and also being used up in the typically KU bands by satellite operations. Now, I want to turn to the United States. I just basically updated and replaced the diagram on sort of the right and saying in the United States, we're looking at a number of different bands. First, basically the FCC has been looking at 12.7 to 13.25 gigahertz. Again, KU band, heavily satellite usage. Satellite community would not like to see that go. They would like to expand their satellite services much more into this band. Now let me take the other 3 bands that are under, which are shown in red. 3.1 to 3.45 gigahertz. Okay, that's being used in certain parts of the world, but it's a primary band being used by radars, okay, today. This is one that's being studied, but will be, again, a difficult band. Much more interest in the 7.125 to 8.4 gigahertz band. I'll show you that in a second. And then the 30.376 band, again, millimeter wave, and that's really something that's been on the table for a while, but just trying to figure out how that all fits together. So, without getting into that, I just wanted to sort of show you the complexity of what's in the 7.1.25 to 8 gigahertz band. The key thing here is, this is sort of the band here, a lot of satellite systems, fixed satellite systems, satellite to Earth, Earth to satellite, maritime mobile satellite, military. Usage is a very prominent thing in the band for military satellite systems. And there's also the ultra-wideband folks who have short-range ultra-wideband, like to use some of that band, particularly channel 9, albeit they have no formal regulatory status, but you know, there is usage for that in the band also. So it's a complex band. Studies are going to be going on to see what we can do in that band. We're hopeful that we're going to be able to come up with some type of arrangement to be able to share it with some of these existing services, perhaps move some others around. But please stay tuned. Okay, now let me move on to, hey, what do we think we could get with some of this? Actually, we're actually quite positive that we're going to get a reasonable amount of gain. Now, a lot of the operators are actually interested not only in being able to get more spectrum, but can we take some of our spectrum that we've had for a while and get more efficiency out of them, particularly the lower band spectrum, the FDD spectrum. 4G systems have been around. Okay, by the time we're going to be ready to be really deploying 6G, we'll be around for about 20 years. And it's time for maybe a refresh of equipment. So we get newer equipment, better performing equipment. Let's try to move to the next G, and we can get some real performance things. We can move more and more to maybe better adaptive antenna systems. Not only that, many other little enhancements that can be done. Juho talked about some of those from the Samsung perspective. For example, we can do a little bit of guard band reduction for FDD. Basically, we can do some enhancements in our coding and some of our modulation to do that. For example, Juho mentioned LDPC enhancements. We think we can do that, particularly which will help on decoding complexity, particularly for higher rates, which is a direction we're clearly going to, which will reduce, as I said, power consumption and such. Do a number of optimizations for our reference signals, symbols, do a lot more power management issues, maybe some adjustments on the waveforms, some adjustments, and better enhance some of the MIMO capabilities. Again, overall, we think we can perhaps get about a 50% gain in overall performance and capacity on these systems, which is reasonable. By the way, one of the things that I mentioned is we've been looking a lot about how do we deal massive MIMO. We sometimes, and we've had a term which I don't particularly like, but I'll just say giga-MIMO, because it's not 10 to the 9th antenna elements, it's larger MIMO, numbers of antenna elements, maybe 2,000 antenna elements going in there in some of these bands. But the point being, we're able to up our antenna and up the performance, and I previously mentioned what Starlink is doing, and I think we can do things quite effectively there also. Now, let me move on here and talk a little bit about AI. Everybody is talking about AI, and Qualcomm has been involved in AI for many years. In fact, if you look at most of our phones, we have AI neural processors on our phones that applications are using today. Okay, so just go get a more recent phone in the past few years, you have a neural processor from Qualcomm on it. Okay, those are for applications. They're also being used to help solve the communications part of the problem. So, where does really AI fit? Well, to some extent, it really helps with some of these problems which are hard to model. For example, handoff is a very tricky problem. How do you do things like beam management? Okay, nonlinear aspects of it, okay? And so we can look at applying some of these things in here. Now, we have to be very careful that we can do this in a power-efficient manner, particularly in a handset. So many of the traditional techniques will be used, but we'll be augmenting them with some more of these sophisticated techniques that will be using some of the AI processing in a certain way. So, for example, one of the first things that we did was we did a lot of work at millimeter wave. Millimeter wave is really tricky in terms of beam management because the signal reflects off of amazingly small devices because of the very short wavelength of it. You can have a little pole out there in the yard and it'll be a big reflector, okay? And so just moving sometimes centimeters will change the beams that you have to do, okay? And the problem is if you want to have good performance and particularly good real-time performance, such as you would like to have for XR or something like that, you really need to have a very dynamic antenna management system there. This is being done, and we're bringing this type of technology into our more recent cell phones. So other things that will be happening here in 6G. Everybody's been talking about wireless sensing, integrated sensing and communications, ISAC. Been a 3GPP study for a while. Okay, it's possible. I think there are a number of challenges here. One of the challenges, we do this sensing in a traditional cellular network. How can we get the data that we're going to pick up and map it into something that's actually usable? Good technical challenge. However, there's also the other question, is how do we make money from this type of capability? So we can do the technology. That's the question. How do we actually make it happen out there? Better positioning, user positioning of our devices out there, in addition, of course, to the communications. I think I'm getting close to the end of my time, so let me just quickly skip over this one. I wanted to talk a little bit about the direction of open systems. And this is one that I think has been one of the key movements that's really been happening in 5G. And I expect it will be really much more part of 6G going forward. So I think we got it going a little bit late in 5G to really be, for many of the early deployments, such as we had in Korea, a big influencer. But the idea of the Open RAN Alliance and really building an open front haul. Okay, so we have a separate radio unit and a distributed unit DU. There's also formerly part of it a CU, but the key thing people focused on is the open front haul capability. Also in the O-RAN Alliance, they're working on the RIC and near real-time RIC, et cetera. But right now, the focus, at least on technology and deployments, have been on this open front haul. And why about that is, well, it really allows us to match, or call it mix and match potentially, equipment between vendors. So what some of us are hoping is that we'll be able to have a greater, in some sense, mix of radios. So we can build everything from the very small little radios that could be just mounted on the wall, just like we do Wi-Fi access points, to the very large macro cells. And we can do this effectively and efficiently. Now, there's been a lot of work. The United States has been very, very interested in that. Many other countries around the world have centers for testing these interfaces and such. And we're starting to see equipment emerge that is basically beginning to be compliant with the specification, and I will be seeing more of that going forward. But what I expect to see from the get-go is much more lock in sync for 6G, that we will get the specifications from the O-RAN Alliance sort of at the same time we get the specifications from 3GPP, nearly in sync, hopefully, and so that we'll have our equipment get-go for 6G that will be compliant along these lines. Another thing that I think we should be thinking about, and we start looking at the expansion of the data on our networks. There are various estimates of what the data is going to increase. You know, the Ericsson report says it's going to be about worldwide about 20% a year. You know, the United States, I just saw an estimate from CTIA, by 2032, we're going to have 4 times the load on our networks and such. So we can go after spectrum. But as I was trying to show earlier, spectrum is difficult to get, and we're going to be sharing it with incumbents. The other question is, can we be more efficient using our existing spectrum by other mechanisms? One way to perhaps reduce is to reduce both the cost of ownership and becoming more efficient is that basically we share radio equipment, okay? You put up a radio at a site and maybe all 3 operators use it, okay? Now, we can think of fixed partitions. Typically, you know, in many countries, hey, the spectrum is, let's say there's 3 operators, 1/3, 1/3, 1/3. Some operators are bigger, have more load than others. Maybe we can divide that frequency split up more intelligently. 60, 30, you know, 10, whatever. Okay? Or we can even think, and you can talk about even more sophisticated techniques where we use it. And we basically are using, I will call it the fundamental things of queuing theory and all that to get more efficiency out of our networks. Now, there are regulatory challenges in this, okay? Because operators may say, well, gee, you know, how do operators first have one deployment potentially, at least of the radio units?
Dr.
Second
Tiedmann,
thing
Dr. Tiedmann,
that we have to deal with is, hey, if you're going to communicate with each other on how do you do the split, how does this really work and deal with anti-competitive or antitrust types of issues? So, thinking about this, really to think about, and something we can really start thinking about, how do we do our deployments maybe slightly different in the future and get efficiency. And so, let me end in saying really, there's a lot of other challenges. And I'm showing here a drone type, which everybody's looking at, perhaps for delivery, not only for that, but for doing sensing power lines and everything like that. We've been trying to move to get this type of services really going that are long distance and using our cellular network. I'm just saying there are challenges in making this happen, and these are challenges that we all should be addressing and trying to face. For example, going to the spectrum issue. Many countries have limitations on what spectrum we can actually operate an aeronautical vehicle, which is this is classed as potentially. So we may need to do regulatory adjustments here. So I'm just making the comment that there's a lot of challenges, a lot of opportunities, and it's up for all of us to really work on a lot of these things. And the way I like to think of it is 6G is a technology, which 3GPP is going to work on. But it's also an opportunity for us to really enhance our IMT cellular networks in much broader ways than just coming up with, in addition, the technology from 3GPP, which I'm sure all the companies who are involved will work to make it great. Thank you all.